Here we see bright annealed stainless steel coils ready to be slit into strip or cut into sheet. Some coils are in their raw state awaiting polishing. Others have already been through the polishing process. The polished coils have been interleaved with a layer of backing paper to protect the surface finish. An individual coil can easily be worth several £1000s. Before polishing, the coil is placed onto a motor-driven roller and completely fed through the machine. At the far end of the line, the operator feeds the end of the sheet onto a recoiling roller. The tension between these two rollers is key to maintaining an accurate finish. The microprocessor control allows the tension, speed of rollers and position of the grinders to be constantly monitored and accurately adjusted. The rollers are driven by DC motors, which provide continuous single direction travel. The polishing belts are effectively large sanding belts, travelling at approximately 2000 revs per minute. Tension is adjusted manually by the operator using the two screw handles. Once the operator has correctly tensioned the system, the whole polishing sequence is monitored and controlled through the HMI, which provides detailed feedback to the operator and enables the input of adjustments. Once the system is fully operational, the polished surface arrives at the roller where a protective layer of paper is interleaved with the sheet. The operator uses a console to monitor the entire process and make fine adjustments to the quality of the polished surface. The quality of the surface finish is dependent upon the intended use of the sheet. For example, aluminium oxide is used to polish a very fine surface for food. This highly polished surface restricts bacterial growth. Key to the quality of surface finish is the correct tensioning of the rollers. This is achieved by using a PLC microcontroller, which feeds back direct to the operator, who calibrates the position of the rollers mechanically. This is very similar to the process of calibrating a sensor on a PIC microcontroller in school. When pressed onto the sheet, the grinding action of the belt generates torque onto the roller drive motors. As the load of the motors increases, so does the current they consume. The PLC measures this change in current and feeds this information back to the controller, who receives a readout of the current in amps. The operator uses this information to set the correct load.